Hello, I'm Vaishali Pula. This is my final project in MIS 5470. This project focuses on clustering methods to NHTSA vehicle complaints to explore their potential safety trends. And here comes the overview. To begin, here's an overview of how I approached the entire analysis and the tools I used at each stage. The goal of this project is to group NHTSA vehicle complaints using clustering techniques. Here I focused on complaints for Ford, Toyota, and Tesla from 2020 to 2024 model years. First, I used R to clean the data and organize a large data set of complaints to understand the basic structure of the data. Then, with Python, I used for clustering algorithms to see whether the complaints form meaningful groups. The goal was not just to create clusters, but to interpret what they represent. For example, whether certain issues tend to occur at similar mileages or with specific model years. The motivation behind this was before diving into the data, it's important to understand why this problem matters. I mean, what questions guided the analysis? NHTSA complaints are incredibly valuable because they come directly from vehicle owners, but the volume is too large to manually review every one of them. That's where clustering becomes useful. It can help summarize the landscape of complaints. Two key questions were focused on: can complaints be grouped in a way that reveals meaningful safety trends? Do different clustering methods provide similar insights, or do they behave differently? The data source and scope was how I pay to ensure meaningful clustering results. The raw data set was massive again and very unstructured. So the first step was to filter it down to something workable, and which gave me around 5,400 complaints here. I then isolated the variables most relevant to safety analysis, things like mileage, injury indicators, model year, and of course the complaint narrative too. Looking at model years gives us our first sense of how complaints are distributed across the vehicles we selected. What we see here is that 2020 models have significantly more complaints than newer models. This doesn't necessarily mean 2020 cars are worse. It simply reflects that they have been on the road longer. Understanding this time related bias is important because it influences how we interpret the clustering results later on. This is the Spearman correlation again. Uh, Before performing the analysis, I examined how the numeric variables relate to each other to understand what might drive separation. For example, mileage was fairly independent from the other variables, which is good. It means mileage can contribute meaningfully to cluster separation. Meanwhile, even injuries and deaths also correlate strongly, which is expected. But this also tells us those severity features might need careful interpretation. Since mileage is a major factor in vehicle behavior, I took a closer look at how complaint mileage is distributed. Most complaints come from vehicles with lower mileage. You can see here. This aligns with typical consumer behavior. Again, people tend to report problems early, especially if they believe something is abnormal. Here in this plot, Ford shows a wider mileage spread, suggesting that its complaints come from a more diverse set of usage conditions. To understand mileage patterns more deeply, I compared mileage across both manufacturers and also model years. When we look more closely by make and by model year, we can clearly see the mileage progression. Older model years naturally accumulate more miles, which shows up as higher medians in the box plots. These visual patterns gave me confidence that the mileage variable would help me to differentiate in the clustering analysis. Next, since the raw mileage values included extreme outliers, I adjusted to visualization so the plots were a little readable. It's important to emphasize that this was done only for visualization. The clustering model uses all the actual uncapped mileage values here. And coming to the part of clustering, the procedure was done in Python again. Once the data was cleaned and standardized, I then applied clustering to see whether the complaints naturally form meaningful groups. And I applied two algorithms over here, k-means and hierarchical clustering. Using two different algorithms helps validate whether the patterns we see are real or algorithm specific. The main idea was to see if the complaints naturally form groups based on mileage, year, or severity, and whether those groups provide meaningful insights. Before running k-means or hierarchical, I needed to determine how many clusters would provide the best balance of detail for the and clarity. To determine the number, I use the elbow plot here and select scores. Both methods pointed to four clusters as a good balance. Enough structure to be interesting, but not so many groups that interpretation again becomes noisy over here. Once the clusters were generated, the next step was to evaluate how the complaints distributed across each group in k-means as well as hierarchical. What's interesting is that both algorithms produced a large dominant cluster and a couple of smaller, more specialized groups. This is exactly the type of pattern we expect in the real world data because most issues fall into common categories while a few represent unusual or more severe cases over here. The consistency between both the models, again, both the methods suggest the underlying data structure is stable over here. And breaking down again the clusters by manufacturer helps us understand whether certain brands dominate specific complaint patterns. When we overlay the vehicle makes on the clusters, we see that Ford has the widest distribution across all the clusters, and this tells us Ford complaints are more varied, possibly due to the broader usage scenarios or simply higher sales volume. Toyota and Tesla complaints fall into more predictable patterns over here again. And one of the clearest findings was that both clustering methods grouped complaints by mileage levels. We see naturally again low, mid, and high mileage complaint groups. Again, K means tends to isolate extremes more aggressively, while hierarchical produces smoother transitions. Either way, the mileage is a strong differentiator in how complaints behave over here. To further validate the clusters, I used PCA to visualize them in two dimensions. Both methods show a reasonably clean separation, meaning the feature space supports meaningful clustering again. So k-means shows slightly better defined boundaries, which aligns with the select scores we saw earlier. It was high for the k-means. Bringing it all together, here are the key findings and what the clustering results tells us about the complaint data. Both clustering methods identified meaningful structure in the complaint data. K-means performed slightly better based on the score and visual separation. The clusters reflect initiative patterns such as failures occurring early in vehicle life or issues associated with high mileage. These insights can support further work such as text based topic modeling or identifying high risk complaint categories. This approach may be extended by incorporating text features also, I mean NLP on complaint descriptions or manufacturer specific analysis in the future work. Thank you. so much for this opportunity.